Okay, then yeah, welcome to this session. Thanks of all again for Go Turkey for hosting this event and make it possible that we can present such interesting topics. And some of the topics I already visited before were really interesting. So let me start with my one. So I want to show you, I want to answer the question actually to say, okay, should I use Make or should I not Make? What are the alternatives we have to build our Go applications, for example? So that's an interesting question. I will lead to this, why I came up with this question to say, is there something else I can use, especially with me? And I will go into this. So just quickly introduce myself. So my name is Engin Diri. I'm working in the Schwarz Group. These are the persons probably some of you may know or may not know are the persons behind Lidl and Kaufland. So it's a discounter and a retailer, and Kaufland is the bigger discounter. I'm working in the IT department of the Schwarz Group and delivering different kind of projects to our customer. I'm mainly in the transformation, cloud transformation enablement around and being occupied and helping different projects to do the cloud transformation. So that's very interesting. And of course, I'm also on Twitter. So if you really want to see some memes and sometimes technical stuff, feel free to follow me on Twitter or Instagram. So that's completely fine. Okay. The agenda for today. So I just want to go quickly through how to build a Go app. That's really interesting. Just a refresher. I know that most of you, because it's a Go conference, will probably know like this, but it's always good to see again where everything started and then go through the different topics to say, okay, what are the alternatives? So we know, for example, there is a possibility called Mage where we can use, for example, Mage. We have the opportunity with Task. So there's a tool called Task we can use. We have, as Hussein just before mentioned, we have also GoReleaser. I would call the Swiss Army knife of for Go applications. And of course, we have this little thing called the Dogger multi-stage builds. And I want to show this also in an example. And after all, we have enough time for questions. And I'm really curious to see what's your feedback on this. Okay, so again, just a little bit background to start from where I come from, because I found this interesting. For me, for example, Go is not my first language. So I moved from classical language. So my background is more, I started my university and my study and my first work career working heavily with Java. So you can imagine the stuff with Java SE, moving up the whole stack, discovering Spring, and front-end wise, I was already on the JavaScript train, so using also there heavily the JavaScript frameworks which were available at this time, and the most famous one you already know with Angular, Vue at the moment. So my background to build the code I created for on the Java side is Maven, for example. Everybody knows. So I have an abstraction inside. We use XML, for example. I know that I have a defined structure to create the stuff. I have my tags. I can put my build plugins in, and I know everything gets executed in this order. There is a fixed defined life cycle behind this. So this is one of my point I heavily used and get used to build my applications. And Gradle, of course. I mean, everybody knows. I mean, if you're still working with Android, for example, you probably also use Gradle to build your application or your mobile application or whatever you're going to build. So also there, we have, again, an abstraction layer between our actual project. We have a defined structure. We have a defined DSL language, for example, where we can follow the pattern. So this is also very interesting and very guided. And of course, with Node, everybody knows with the package JSON, we could put script tags inside, and then we can execute also the applications. But there's also a little plot twist inside. When I worked, I'm not sure anymore if you still use this nowadays, but when I worked, for example, with front-end project, I also used Gulp. And this was very interesting because I could use, for example, JavaScript to build my JavaScript project. I found this very interesting. It's like the whole infrastructure code part, for example, like Pulumi is doing, to use a real language to define the deployment on a cloud provider or whatever. So that's really interesting. And of course, Grunt. So these are the technologies I always used to create my application. And where is it? Of course, I also used Make. I mean, there were some times where I had some really C programs where some Makefiles were already there, and I had to use Make. And this is also where I'm coming from to say, okay, Make was for me always something I could not really get my head around. I mean, it was very close to Bash, and if I need to write some Bash files, for me it's always like this. I write it, 5 minutes later I forgot about it, and I have to look it up again. I'm really, the only time I'm really heavily on Stack Overflow and in the internet looking up for resources was always when I have some kind of contact with Bash files, because I don't know why I'm not able to memorize this stuff. So this is really a thing. And that's the thing. I really feel uncomfortable. This is really one of the times I feel like I don't know what I'm doing and I have to look it up. And when I come to my Bash scripts I wrote, I'm like, what the hell did I do there? And it feels like a Frankenstein application. You know, you copy paste the stuff together, you're happy, you pray, and it works. And you're like, okay, I'm done. I never want to see this stuff. So that's for me the question. And when I started with Go, it was at the beginning of this year. So as I said, I'm not a Go developer since years. So I started with version 1.16. I also encountered quickly that many projects, Hussein also explained this, if you're in the open source world and you want to contribute or you want to create your own open source project, you will encounter always this Makefiles. So that's the thing. So there are, for me, it was like, oh, I need to get my head around the Make stuff. But happily, there are alternatives. I mean, there are alternatives, and are they easier? That's another question. I mean, I cannot say, and we will see this also in the examples I prepared. It's not that you will get maybe an easier approach to the Makefiles. So maybe you have to see what you're changing. You say, okay, am I going maybe for the readability? Am I going maybe for the native integration of the other solutions? So you have to see which solution fits better. But it was for me when I tried the different alternatives and we used them in our company, for example, and in our projects, I always was, okay, I have to weight both stuff and I have to say, okay, what I want to do, which one I can scale out. Maybe I'm not anymore in the project and there are people getting this project. What level are they? What expecting they? Maybe they are strong with Make and they want to continue Make. So it's really interesting questions, but it's worth to see what alternatives we have and decide then on a case by case if you want to continue with one solution or you want to abandon the other one. So again, the question is which solution, which automation tool solution I should use. And here again, that's maybe something it comes up more and more, and you already maybe heard this also in your life. It really depends again. It really depends what's going on. But again, it's good to know the alternatives, and then you can decide if your use case, if your project, what maturity level has your project, to decide it's absolutely fine to use this piece of technology. And if you grow or you outgrow the current situation, you can still change the stuff. So that's very interesting also. Okay, so quickly, I don't want to bore you too much, a little bit about the basic stuff to say, okay, what's the way we actually build our Go application? And again, I would like to go only on the happy path, because as you know, when you write, for example, Go build and you make a -h, you will see plenty of flags you can set. So I'm sure that you can really go mental with all the possibilities. So here again, just a quick thing. So the main way, and this is, I mean, everybody who starts with Go from the hello world use case to whatever bigger application is always using the go build command. And then you can start to refine the stuff to say, okay, what is all in the main package and how I want to rename the binary, what's coming out. Do I have some linker flags I want to set, and so on and so on. But starting point is the go build. So nothing new on this side. And now we add now comes the next step. We know that with Go, we have a cross-compiling. So that's really nice. And Hussein just explained it also when he explained the GitHub Actions, for example, with the Kirmu and enabling this stuff to be sure that you can build and run the application on the different runtimes. Here with Go, we can set different flags, the OS flag, the architecture flag, to say, okay, for which platform we want to build our code. So you see it starts again. Now we are not anymore on the level to say, okay, go build. We start now to add additional stuff. It's not something anymore where you say, okay, I write this in a README, copy paste this. I mean, we are not a machine. We don't want to copy paste the commands all the time. So that's something for sure. And then, as I said before, we start with all the parameters. I mean, the linker flags are the flags, the most obvious one and the one everybody is using, be it here in this use case, just to paste some variables from extern, maybe the version, the commit ID, or whatever you want to put into your project during compile time, you can set with these flags. So as you can see now, things start to grow, and this is not something anymore you put in a README and you copy paste, and you definitely don't want to do it by hand. So it's completely obvious that you want to use some kind of automatism, some kind of description to say, okay, these are the steps. This is a dependency tree. I want to do a Go mod tidy. I want to do a Go mod or a Go test. I want to call Golang CI for the linting stuff. So you already have some kind of dependency graph in your head, and on the different steps you want to perform for creating your release or for creating your binary, be it a test or a release binary. So that's completely fine. So then we come to the golden standard. I mean, then now we come to the situation with Makefiles. I mean, that's really something. When I prepared again, I didn't want to talk about something where people say, hey, that's not true or something like this, but I checked the major external projects, for example, the Kubernetes project or the Prometheus and so on, the stuff we already use every day, and they have all fancy Makefiles. So that's something we encounter already. So is this the gold standard? And I looked around, I was like, okay, what does the people say? Maybe it's just me. I mean, I can be stupid and so on. And okay, I don't understand it. Maybe I'm not this smart as I thought I am. So let me see what other people think about. So I typed in, I went to Twitter, for example. I was just, okay, let me see what people tweet about Makefile. And then boom, comes one tweet in your hand where a person, sorry for the swearing word, he's like, oh my God, this is something... he hates it. So that's very interesting. Or we have another one where it's more politely to say, okay, I'm not a real fan of Bash and Makefiles. Yeah, it's similar to me. That's the same thing. So we see the tendency, but not only on Twitter. I mean, we know on Twitter the people come and wants to complain or something like this. How is it, for example, on Hacker News or on Reddit, for example? And there are also plenty of threads where people just don't feel comfortable with Makefile. They understand the need and they see the benefits maybe, but they don't feel comfortable. And one big thing, for example, this is now just a random Google search where I said, okay, let me look for Makefiles suck, for example. And there are also entry where people are really, really upset about the whole Makefile experience. So that's a really good point to when we go back to our initial question to say, to make or not to make, what are the alternatives? Maybe it's okay, again, to check the alternatives. So I want to quickly prime you on Makefiles to say, okay, what is the deal about this? I mean, some really introduction. I mean, I cannot really go deep into the whole Makefile stuff, but I think it makes sense to just quickly give you some feedback. So again, Makefiles, as you see now from the feedback, from the tweets and the Google results, for example, it looks like they spark some kind of controversy. So it's really like either you hate it, or you love it, or you're in between, something like this. So yeah, I have to use it, but I actually don't want to use it. So Makefiles, I mean, some people would say they are just fancy Bash scripts, and actually they are like this. I mean, they're coordinating like this. They have a unique take on the user experience, on the developer experience. So it's something you really have to get familiar and have to understand, because, okay, this is say it like this, because Makefiles are really, I would not say old, but they are really, and I say that here with battle-proof. I mean, they are not something like a thing from the last couple of years. I mean, Makefiles are there since ages. I mean, in the old times in C and so on, people already wrote Makefiles. So they are battle-proof. I mean, we cannot say that this is something, I don't want to deny the success of them and the way they handle the stuff. So they are battle-proof over time. But as you can see, over the time, we learned new ways of organizing our work, organizing our automation and all this kind of stuff, and increasing our usability and our developer experience. We see that they're coming two worlds together. And now that's the situation. So the unique take of the UX, and it's what makes everything more complicated. Okay, so just a quick overview over the Makefiles. So this is really some stuff where you start, okay, I was also like this, okay, we have our target, we can use our prerequisites, and then we come up with the commands. And this is the shell commands. You write everything in the shell commands. You can define variables on the top of it. So yeah, everything that's still okay. But quickly we come into this situation. So this is actually a real one. I put also the link there. That's the one from Prometheus. So it's from their common Makefile example. And as you can see, it really grows up quite quickly. And again, as I started before to say, I mean, yeah, I understand it. Maybe when I'm working in, maybe I need to deep dive into it because I'm doing some stuff. But the moment I left it, I changed my work and I need to come back maybe a couple of weeks, days later. I'm like, what is this? What did I wrote there? And what is again? And how do you do a loop again in shell? And how do I truncate the stuff? So that's the situation we have. Okay. So let us come to the first alternative. Again, we'll go later into the code, so you will see this little bit code. I thought about maybe to interrupt the slide with the code, but let us just go through the alternatives, and then when we see them again in code, I will remind you and say, okay, this is now the topic of Mage, for example. So we have one of the solutions is Mage. And Mage is a rake-like build tool completely using in Go. So this is really, really interesting. That's a really nice approach. So you can use, it's written completely in Go. It has, I put it here again, it has some helper libraries bundled in, so you can use some functionalities they provide to you, but then everything is in Go. And this is really, really interesting because I can use the full power of Go and the libraries and whatever I want to use. I can create loops and everything. I can even test the stuff and run, for example, my linting also over it. So everything I'm used to during my daily work when I write the application goes now into the way I build the application itself. And this is really, really interesting. And when you look at it and we see later the demonstration, you feel instantly familiar and you're like, okay, that's completely fine. Even when you take it out after a certain time, because you are a Go developer, you're like, oh yeah, okay, that's it. That makes absolutely sense. So Mage is really an interesting stuff. Again, we will see, I mean, you will find also out, okay, this is again, everything which is written in a programming language. You have to keep in mind that you will start also to get some technical depths. So this is like infrastructure as code where you write code. The moment you write this kind of codes, you have to keep in mind that you maybe get some technical depths in, or that you also write rubbish Makefiles or Mage files. So that's something to keep in mind. But definitely very interesting. So we will see this in detail. The other one I call tasks. So the whole don't forget the milk is all about having a task list. So the next candidate is task. It's also written completely in Go itself. And the installation is also quite easy. So you can just install it via brew, for example. It's a single binary you can install. That's very, very interesting. And the plot twist in task is you can use YAML. I mean, I know that YAML is a thing everybody is discussing about. Is YAML good or is YAML bad? But here in this case, it's used a simple YAML file, but completely enriched again with the Go world. So you can use, for example, the Go templating inside of the YAML files, which is really, really nice. And again, you have something very familiar, because when you use, for example, Kubernetes or other technologies, I mean, there are plenty of existing technologies who use also YAML, for example. So in this case, it's actually something, okay, it's well structured. I can see this. I can run again some tools over it to confirm that everything is written. I have a JSON schema file, for example, so I get also there instant feedback if I'm miswrite something or have some issues with the child elements and so on. So this is really, really interesting also here. And Task has also really powerful code generation parts. I mean, when you create, you can set timestamps for generating the files. He will check them and he will not execute the task, for example. If there's already created one and your condition is still valid, he will not recreate the task. And this is also very interesting. And again, you can create whole dependency structures. You can here again say, I built my graph. These are the preconditions I want to do. Or you can call tasks inside tasks. You can create also a task file library where you say, okay, I have some generic task I always want to use also in other projects. So you can create also task file templates, for example, and include them into your actual project. So this is, again, very, very nice functionality. And as I said before, written in Go, using the Go templating, very interesting. So this is the task part. And now we come again. Hussein also mentioned this, and this is something you will 100% encounter when you work in Go, is GoReleaser. This is the absolute Swiss Army knife of build automation release tool, all in one, baked in. I mean, there's so much functionality. You could really literally create a dedicated session just for GoReleaser. But here, it makes absolutely sense to put this also here in place to say, okay, GoReleaser is the automation tool for Go projects. GoReleaser is completely built with CI in mind. So everything, I mean, they have a huge integration part for CIs. They support from Azure DevOps, from GitHub Actions and so on. So everything is really thought for using it in your pipelines. That's very, very interesting to have this already by design thought about when you create this stuff, that you say, okay, one of the primary goals where I'm going to use this is in my CI tools. And again, Hussein also mentioned this, you have plenty of customization options. I mean, you don't need to write any additional stuff. You can say, okay, I want to publish it to my own brew tab, for example. You can configure this. I want to send some Twitter messages when I release my application, for example. So again, there's also much to do. We will see later a little bit in detail how we, for example, then do the use case. So very interesting. And also worth mentioning is, of course, the Dogger multi-stage builds. I mean, this is also very interesting. I found this appealing. I mean, there is some really interesting charm on it, and I will go into this. I mean, I like the way that, for example, I can create immutable builds through fixed versions. So I can run every step in my, I mean, I can put many, many steps into it, and I can run every step in a specific container, in a specific container version. So I can really pinpoint the specific version through the SHA, for example. I mean, I don't even need to write this human readable version, like version 1.0.0 or whatever. I can write the SHA number behind this, and I'm sure whatever I'm doing, as long as the container is still available, either through Docker Hub or through my internal registry like Artifactory or whatever you are using, I will always get this version. And I'm sure when I build the version, when I execute my build, it's as close as the person who wrote the file thought about it. I mean, still you could have not a reproducible build because you somehow missed something. I mean, this is still the possibility. For example, in Node.js, you set some version conditions and he will get the latest version. So this is something not thought. But if you take care and your build is everything set up to create this reproducible builds, what a word, you can be sure that this is really an addition on top of it to have this immutable approach. And with the immutability comes also the reproducible. I always mention this. But here having also the transportability between the different stages. So I can say this multi-stage file runs also on my CI server, but I can use the same one on my local client too. So we have now a common contract, we have a common language created here, and we can be sure that when an error appears, for example, I can at least execute this, for example, in my local machine and see, okay, what is the issue there? So we have something, or our colleague starts in the company and he wants to continue to work on this. You can say, okay, you don't need to create maybe your local Go version. Maybe it's a different Go version. You have 1.17.1 and he has 1.16 or something like this. And then you get maybe some issues and you're like, okay, there's an issue. And you're like, which version do you have? Which version of a supporting tool do you have underneath? And here you can define everything in your multi-stage, and you can be sure, because of the fixed version and the containers you're using, it's always be the same one for every person. And here again, we have one situation here that it depends on the Docker CLI. Yeah, I know there are some projects outside who can use this, who tries to emulate as much as possible from the Docker DSL. I'm not 100% sure that every alternative is running multi-stage builds, for example, perfectly and understands all the stuff. I mean, it could be possible. Last time I checked this, there was the mentioning that some of the Docker DSL commands are not 100% working on this. For me, it doesn't matter because I'm using Docker Desktop, and in my company, they're using also Docker Desktop. So that's completely fine for us. This is a drawback. I'm completely d'accord to use this. Okay, so we set up the scene, and we talked now about different stuff. So let us see how this is going to look like in a demo. So nothing big. So there will be code. I hope that's okay for all of you. And we'll see this in the code. So okay, again, let me open my IDE. So I'm using IntelliJ. So that's it's really not depending on this. And let us see how we created the demo project. So it's a really simple one. I created a simple main Go where we have just a string getting out, and to see a little bit of the injection of external values, I also created a variable and the Go application. So when we say Go build, I hope it's visible for everybody. I will still create a little bit bigger. This one, strangely, you cannot scale. That's really bizarre. Okay, so let us run the application. And we expect now to get the build as unknown and the version as 000 dev. And yeah, absolute. That's what we expected. So hello, GopherConTR, and the build is unknown. That's completely fine too here. And that's it. And if we want to go build the application, I just type it here with go build. Let me not put the LD flags in. And we should get now a binary here. In this case, I'm on a Mac OS system. So, and again, this one is also working perfectly. That's what we expected. So let us see, remove this one. Let us check now the Makefile as a reference. So I created here really a basic Makefile. So again, I defined here in my variables. and everything here. I limited the platforms because I said, okay, here, and also the architectures. I didn't want now to make ARM and all this stuff because then we wait for ages. The binary name, the version, here the build version I will get from Git. So I put a Git command into it, and then here's also the LD flags, the dist folder, that's completely fine. Here, some good practices, having this command. So if somebody comes here and just type make, he will get all the available commands. That's really interesting. And then I have all the steps, for example, I want to do. So I have a clean step because I want to delete my dist folder. I have the build all, where I want to create all the what's the name? All the architecture version I defined on top of it. So you see it starts already here with some fancy loops going on, getting all the shell commands together and cleaning, that's what we say. And again, it's cool, Hussein, props to you. Again, Golang CI linting. I want to get everything linted so I can execute also the linting part. And of course, I can create a Docker image too. So that's the thing. So I create the Docker. In this case, he takes the binary I created and I mean the Linux binary and puts them into the Docker file. So it's really not voluntarily not built to show you a multi-stage build, but to say, okay, I build it somehow, get the binary from the dist folder and put it into the Docker file. So that's completely fine. Okay, then let us create, I mean, we could put tests in and so on. So you can imagine you can really go crazy here with all the things you need for your project, checking out sub-projects and so on. So that's really fine. Let us create now, for example, the build all step. So we say make, I just copy paste this here, build all, and we see the dependency graph gets built up, and he should create everything for us. And let us see, is there a dist folder? Yeah, there is the dist folder, and we have also the different binaries for different platforms. So if we go and call now the GopherCon and the Linux one, not the Linux one, the Mac Arwin one, and you see now we get the same expression before, but here we get the git commit ID we get, and also the version we injected from outside and everything. This is to make it configurable, so that's completely fine. So let us start now with our first alternatives, and we started the presentation, we started with Mage, so we use the same approach, and we're going to use also Mage. So let me clean everything. Okay, so the dist folder is gone. And now we would like to start with Mage. I installed already the binary. There are different ways to install the binaries, and I'm always a fan to let you as a developer decide which way you prefer. So we have, I mean, I can talk again only from me and my experience in my company. We have persons who prefer to use Brew, other persons want to download the stuff. Then we have persons, for example, who use Arcade as a tool to download the binaries they would like to have because they have some specific way to save them. So it's again up to you. We are not talking about this, but if you want to use the Mage, we can just say Mage init, and he will automatically create for me the Mage file with some boilerplate code into it. So we get the annotation on top of it, and we already get our first imports. So that's completely fine. And as you can see, also the first targets displayed. That's also really, really fine here. Okay, so let me, so that's the way you can instantly start. Let me just quickly grab and go get the bibliothèque. So okay, so and then we can use the stuff I created already to not bore you too much. The version for this demo product. So I just translated the make file you just saw before. I translated it into now a Mage file completely written in Go. And again, it's written in Go, and I'm sure everybody has a different approach to tackle the stuff. But for me, I will show you the way I did it here, for example. So as you can see, you can say if I'm not entering a default target, he just should execute. I mean, if I don't say Mage and then a target, for example, he should execute as a default always the build step. And then you see, I create here my variables. I say, okay, for which platforms I want to use this. You can organize this on a different way. You can create structs and put this stuff together and so on and so on. I created my variables here as a constant. So the binary name, the LD flags. And here you see I'm going to use the formatting from Go, the version and the dist folder. And then let us go now into the build step. That's the build all. Here's the build step. And here you can see with the helper library from Mage, I can use, I can create dependencies. I can say, please execute before you execute the build. Please execute the clean target. So the clean target, what he's doing, OS remove all, deleting the dist folder. That's everything we need. I mean, that's what we do in our daily work with Go. Perfectly fine. If we're going for the build step, so we say the clean gets executed, and that's completely fine. Okay, here I'm missing something, but that's good. So we can instantly. So we call also instant dependencies. So we say execute clean, please, and then install also the dependencies. And here install dependencies, for example, is not doing anything else than calling, for example, our Go mod tidy. That's also very fine. And at the end, my Go application gets built. Here in this case, for the specific architecture I'm on, so for my Mac OS, like the one we did before, and setting also some flags with the linker flag. So here with get build, you can see what I'm doing here now is I executing here a command for the Git to get the information and giving the output of this as a return value for my for the formatting for the linker flag. Okay, so again, sorry that it's not zoomable in IntelliJ. So we can now say make Mage and say build, for example. Okay, and then we execute it. And you see he's calling the installing dependencies. He's cleaning the dist folder just in case. And then he's building my application. So we should have, again, here in the dist folder, we have now the specific version like we had before. So I can say no dist. And we go GopherCon. And you see it's working completely fine. That's really cool. So let us go now for the build all step. All. Again, cleaning. Oh, I forgot to go mod. Okay, that's okay because he have it already. And now we see here that he created also the different architectures I said, but as you can see, it's just a for loop. So that's something we already know. I mean, you can go completely crazy again, like you would do in your programming thing. So this is really a simple one, but I just iterated here over the different available platforms or the platforms I would like to build, and he created it. And I just executed here the run command. This is the second helper library from task. So completely fine. And last but not least, let us see how he's creating a Docker file for us, or the Docker build. Here it's the Docker. Let me call Docker. But as you can guess, I'm just calling the command, and he should create for me now the stuff. Okay, you see my Docker engine gets kicked off. And if we run now Docker run GopherCon, we expect hopefully to run Docker run. Okay, looks like he collected a different version. Okay, I have to check this one. never mind. But yeah, that's the thing. Last but not least, when we want to run, for example, the linting again, you can put everything into a dependency and create different targets and so on. So that's completely fine. But as you can see, I can call also the linting stuff. And here you should see I get also error message because, or not an error message, a warning that I could write it probably better than here. There's a simpler version to do this stuff. So that's completely fine. Okay. And yeah, that was the Mage case. So as you see, I feel very familiar for especially because with the grunt, for example, from my front end experience, I really like this because here I feel myself at home and I understood and don't need to come up with some fancy own ways of handling a loop, a condition, or whatever, because this is the stuff I already use in my code. Okay, let us go to the next use case. So let me delete again. This time I use Mage. We say Mage clean. Okay, and it's gone. Okay, now let us take a task file, for example. Again, with task, you install the CLI as you prefer. And then we have also here the possibility with task init. We can create here a task file. Yeah, it's without the A at the end. I created a ticket, so they call it YAML with a A, but here in this case, it's without the A. And you get also a starter definition of your task file. Again, I created also for this one an example. So this is the one translated the Makefile from our simple example. Again, as you can see, I can define, look, let me go up with this. I can create environmental variables. I can create variables, lists. Everything is possible. I can even create variables where the content is dynamically. So here in this case, the build version, he executes a shell script for me. A shell command where I execute the git command, for example. And then, as you can see, I can put now the values, and everybody who used Go templating will like, wow, I noticed that's Go templating. Yeah, that's Go templating. You can use the Go template engine and just put the stuff in. Again, the variables here, the platforms I'm going to do. And similar to the other approaches, we create our clean tasks and we create our setup tasks, for example. And as you can see here, I can create, again, dependencies. I can say to him, hey, when I call the setup, please call the clean before. So I'm always sure to have a clean slate when I do something. I can create a description and I can go here again, put everything underneath. I can call a task if I want to call a specific task, because a dependency can be possible that it's not executing in the right order. So if you want to be sure that the task gets called, for example, you can explicitly call a task. You don't need to rely maybe on the dependency because there's a racing condition going on and you want to eliminate this one. So again, here you have much to do. By the way, I'm using, as you can see, GitHub Autopilot. So that helps also quite a lot for creating this stuff. And here again, test linting. We already saw this. So linting depends on setup and setup depends on clean. So you would expect later to see all the different steps going down. And here we have again the build. You see, I'm using the templates. I'm using the variables inside. The Dogger one is the same like before. I'm calling my Dogger build. I'm using the variables I defined before. Now, the build all is a little bit, what I said before in the beginning, is everything as easy, or is there some other things, the trade-offs, for example? And I found, for example, creating the multi-architecture build in this case, I used heavily the Go templating, creating also the range to iterate over the different platforms I am available. Yes, you see, it can get a little bit verbose also here in this case, but still everything is understandable. So that's completely fine for me. And I see I built everything. So let me try a task. Let us use the, in this case, we still use here the task, and let us do the task build all. You see he cleans the dist folder. He creates here the go mod tidy. He's calling again to download the latest modules, and then he's executing the build. And we would expect again a dist folder. Yeah, absolutely fine. We have again our application, our binary inside, and we can call the GopherCon Darwin again. And as you can see, it has also the values injected in because I defined them here again here with the short version, for example. Let us not use the short version to show that it's not something pre-built from the last time. And we call, and you see that's perfectly here. It's now the long version of the Git. That's fine here. And again, yeah, maybe I should show one part here. As you can see, the generate, for example, this task gets only executed when something changes. For example, he takes care. That's what I meant with the code generation. For example, you can completely jump over tasks because nothing changed, and you gain also here very quick speed, and everything is inbuilt again. So that's really, really nice. Yeah, let us also make the Docker build. So again, this is the Docker build for uploading the specific version. Let us see if it's now working. Docker run, probably not. Okay, yeah, this one is working. So he picked up the correct version from the dist folder, and I created again a Docker image or a container out of it. Here, it's everything written. So that's completely fine too. This is the task approach. Again, I will put in the slides, there are the links, and I will show them later on. Again, there's much more you can do. I mean, this is really the tip of the iceberg of the possibilities you have with task file, for example. So, and the next one is our GoReleaser. So here again, let me, delete, let me clean everything. So there's nothing then. You can again install the GoReleaser CLI again the way you prefer. So nothing changed here. And we have again also an init command here. So when we type GoReleaser init, he will create for us a GoReleaser file with some starting points. And this starting YAML file is already mighty. I mean, you hardly need to change anything for executing it. That's really, really nice. And I just added again because we wanted to show the substitution. So here I created the substitution. There's only one thing I've written my own Docker file for this. It's just because I did not want to modify the other one. Docker file, GoReleaser. So cancel this one, and we take this one. It's just a minor thing, and I didn't want to spend now too much time with changing the stuff. So let us see how the anatomy of the GoReleaser file is. Again, here we have the project name. So here in this case is GopherCon Turkey 2021. You can change this again. I mean, if you don't add the project name, he takes a default from your folder name. So then it's similar. I just wanted to show that you can set this on different thing. I have here the possibility to execute so-called hooks, where I can say, okay, please always run following commands. In this case, I said, okay, I want always to get go mod tidy. I want to run also the linting. Maybe there comes an exit value, and I don't want that he's continuing his work. And then you see here the build tag, and here I can define everything what is important for me for my build. There are many, many defaults. You can see the documentation of the GoReleaser page. There's much you can do and much to change from the architecture, from the ARM architecture. There's really everything thought about. Here again, what I said before, the operating systems, the architecture here on the AMD, on the 64 architecture, the LD flags, similar to the ones you saw before. GoReleaser has an advantage. He has also many default values saved. So when you go on the documentation page, you will see plenty of default values or default variables you can just instantly use. For example, short commit. As you see, I did not need to enter some git whatever command. I can just say short commit, and he's putting the short commit already inside. And that's really comes handy because it reduces everything I write, and so I have no liability here because I don't need to maintain this code, and I'm not need to change this or have some maybe technical depths inside or some flaws inside. And then, as Hussein also mentioned, there are plenty of possibilities to customize this. For example, I can rename the archive files, what he's creating. I can zip them automatically. I can gzip them. There's everything inside. And here I say also, please create also a Dogger file for me. And now comes the magic to execute this. So I can say GoReleaser, release. Here in this case, I say to him, hey, create a snapshot, please. It's not a release version where he executes also the upload to the GitHub release page, for example, because I want to execute this locally. So I can say GoReleaser, release snapshot. Automatically release the dist folder. You see, I don't need to take care about the dist folder. And now, hopefully, it runs. Okay, now we have the Golang issue. So let me disable this. Don't do this in your real projects. And you see, he's creating here now the stuff I would like to have. And also my Dogger image gets created. So I can say now Dogger run. And what is the image template here? It's GopherCon. So I can say, please execute this one. And you see, it's also giving me the short commit. Again, I did not have to use any git whatever. I could execute. I can just use the predefined variables. The team from GoReleaser is providing me completely fine. And when we see what GoReleaser created for us, the dist folder and some additional meta informations. But again, I have also my binaries. I just did not put them into folders or I zipped them because I just wanted to show you now the beauty of it. But again, everything is configurable. That's completely fine. Okay, so that's this place. And now, last but not least, to finish, to slowly wrap up the session is going now to the multi-stage. And for this, I created here a multi-stage file. So let me get this also here in a file. So we say Dogger file multi. I will commit this later into the Git repository, and if you are fancy, you can check this out. So here, last step, this again is a very simple one, and you can really go crazy. You can create also your own Dogger tool containers where you bundle specific tools or CLIs into your main container for building, for example. So we have here the step randomly called builder. So I take here the Golang version, I take the Alpine version, and you see I say go mod tidy. I could also call the Golang CLI, for example, if I created another container on top of it with the Golang CLI inside and could say, okay, please execute the Golang CLI. In this case, I did not do this. And you see again, I will build the application again. In this case, I know that my target, everything will be a Linux based, so I did not set any specific version for the architecture inside. If I wanted to create, for example, a multi-arch container, then I could also enter this information inside. That's no problem here. In this case, I know it's only running on a Linux system. It's a demo application. And here again, we see we can take now the artifacts created and just the artifacts, that's fine. He discards everything else. My image will be still slow. I use here, for example, the Alpine, but yeah, you could use also the Scratch, for example. And I get the output from the other container as an input for my next step. And then I just can continue. In this case, I will create a user because I don't want to run the stuff as root or whatever user, and take care that my application gets executed. And now there comes a thing where you say, okay, this is something, maybe you have to start to mix this because nobody can remember now this build command I put here inside. Let me put it here also to talk about this. So I call the Dogger build, like in the other things. I say which file he should execute here, the container name or the image name. And here you can see I put the build args as a variable inside. But again, there's a different ways to handle this also. With end files you can work and so on. So everything is possible. But here, just to make a demo, and now I execute this, and he should build. You see, everything gets freshly built. Here in this case, sometimes he reuses the cache. That's also speed up my build process. You see, it really was a quick build process. The bigger your project, the more advantage you have from caching different layers, for example. And if we run now the triple X or the 6x container, we should now get also here, hello GopherCon, and the version. Okay, so that's all the possibilities. Let me look, we have 3 minutes left. So let me quickly go back to the slides. Okay, so demo is done. What's my conclusion? You don't need to use Make. That's what I can say. So there are possibilities. There are good possibilities. There are worse possibilities. There are possibilities you need to see if they fit into your project, into your thing. But the message we started with to do Make or not Make, you don't need. You can use whatever fits to you and your skill set and your company. Okay, questions?